To determine specific heat capacity of a given solid by the method of mixture. Heat is a form of energy which produces the sensation of warmth. Principle of calorimeter: whenever substances at different temperatures are mixed, then heat is lost by hot substance and gained by cold substance. If there is no loss of heat, then heat loss is equal to heat gained.
Ma'am, how can we determine specific heat capacity of a given solid by the method of mixture?
When a solid at high temperature is dropped in a calorimeter containing cold water, then the hot solid loses heat, whereas calorimeter and cold water gains heat till temperature becomes same throughout. If there is no heat loss, then according to principle of calorimeter, heat lost by solid is equal to heat gained by calorimeter and water. Let's do an experiment to determine specific heat capacity of a given solid by the method of mixture. Our aim here is to determine specific heat capacity of a given solid by the method of mixture. Materials required are a hypsometer, calorimeter, stirrer, a lid, an outer jacket, 2 half-degree thermometers, given solid in powdered form or in small pieces, balance, weight box, cold water, clamp stand. Procedure: first of all, take a beaker containing water and suspend 2 thermometers A and B. Note the reading of both thermometers. Take one thermometer A as standard and find the correction applied to other thermometer B. Take water in hypsometer. Put a small quantity of solid in copper tube of hypsometer. Now insert thermometer B in it and then put remaining quantity of solid in copper tube in such a way that thermometer is surrounded by solid uniformly. Place hypsometer on a Bunsen burner. Set the physical balance in such a way that its plumb line remains vertical and beam oscillates equally on both sides. Take a clean calorimeter with stirrer and weigh it using a physical balance. Now put a lid over calorimeter and weigh it using a physical balance. Fill the calorimeter about half of its capacity with water having temperature about 8 to 10 degrees Celsius below the room temperature. Weigh it using a physical balance. When the temperature of solid placed in hypsometer becomes steady for about 10 minutes, then note it and apply correction. Note the temperature of the water filled in the outer jacket of calorimeter. Quickly remove the cork along with thermometer B from copper tube of hypsometer. Take out the tube from hypsometer, lift its lid and quickly transfer the solid to the calorimeter. Stir the mixture while the temperature of mixture becomes steady. Note down the final temperature of the mixture. Remove the thermometer A from the calorimeter carefully and weigh the calorimeter with mixture and lid. Observation: reading of thermometer A is equal to TA is equal to X degrees Celsius. Reading of thermometer B is equal to TB is equal to X degrees Celsius. Correction to be applied to thermometer B is equal to TA minus TB is equal to X degrees Celsius. Mass of calorimeter and stirrer M is equal to X gram. Specific heat of copper calorimeter is equal to 0.095 calorie per gram. Water equivalent of calorimeter W is equal to M 0.095 is equal to X gram. Mass of calorimeter plus stirrer plus lid M1 is equal to X gram. Mass of calorimeter plus stirrer plus lid plus cold water M2 is equal to x gram. Steady temperature of hot solid T is equal to x degrees Celsius. Corrected temperature of hot solid T is equal to T plus Ta minus Tb is equal to x degrees Celsius. Temperature of cold water T is equal to x degrees Celsius. Temperature of mixture T dash is equal to x degrees Celsius. Mass of calorimeter, stirrer, lid, cold water and solid M3 is equal to x gram. Calculations. Mass of cold water M2 minus M1 is equal to x gram. Mass of hot solid M3 minus M2 is equal to x gram. Rise of temperature of cold water and calorimeter T dash minus T is equal to x degrees Celsius. Fall in temperature of solid T minus T dash is equal to x degrees Celsius. Heat gained by calorimeter, stirrer and cold water W plus M2 minus M1 into T dash minus T is equal to x calorie. Heat lost by solid M3 minus M2 S T minus T dash is equal to x calorie. Here S is the specific heat of the solid which is to be determined. Since, according to principle of calorimetry, heat lost is equal to heat gained. M3 minus M2 S T minus T dash is equal to W plus M2 minus M1 T dash minus T, or S is equal to W plus M2 minus M1 into T dash minus T upon M3 minus M2 T minus T dash is equal to calorie gram raised to the power minus 1 degree Celsius raised to the power minus 1. Result. Specific heat capacity of given solid by method of mixture is calorie gram raised to the power minus 1 degree Celsius raised to the power minus 1. Precautions. One thermometer should be taken as standard and correction should be noted for second thermometer. Thermometer inserted in solid and hypsometer should be surrounded by solid uniformly. Sufficient water should be taken in hypsometer. Temperature of solid should be noted when it remains steady for about 10 minutes. Calorimeter should be polished from outside to avoid excessive radiation losses. Solid should be dropped quickly but gently without splashing water in calorimeter. Solid should have no chemical reaction with water. Temperature of cold water should not be below the dew point. Final temperature of the mixture should be noted after through stirring. Sources of error. Thermometers used in experiment may not be standard. Some heat is lost in conduction, convection, and radiation in spite of maximum precautions. Some heat is lost while transferring hot solid into calorimeter.
Thank you, ma'am, for this knowledgeable experiment.